exactly are black holes? Well, black holes are a place in space where the pull of gravity is so strong that no matter can escape. How does black hole get such a massive gravitational pull? Well, before black hole became a black hole, it used to be a large star, and that large star got compressed into a small space due to some circumstances. And giving that small place, the gravitational pull of the large star, as the gravitational pull also got denser, the gravitational pull increased by now. So how are these black holes made? Well, a star is a massive collection of gases, and in the star's core, a process called nuclear fission is going on, in which hydrogen particles combine together to make helium particles, and this process goes on, and helium particles combine together to make carbon. And the more massive the star is, the heavier the element it can condense. So, if a star is massive enough, it can create the particle of iron. So, iron particle, but the fission of iron particle does not generate any energy. So, the iron keeps piling up in the core, and after a while, the core completely gets interrupted particles which cannot give energy. So the star does not get energy anymore to fight against its own gravity. So the gravity pushes it and compresses it down to a point, and it implodes. And that implosion is called supernova, and that gives the creation of black hole. So black hole has mainly three parts. The accretion disk of the black hole, where the matter which is on the boundary of black hole is seen. That is the only part of black hole which we can see. The part inside it is called the event horizon. Event horizon is also called the line of no return, because if anything falls inside it, it cannot come back. And the score of black hole is called singularity. It is an extremely dense point. So, can these black hole even die? Well, yes, they can. Even vacuum is not completely empty. Yeah, virtual particles keep popping in and out of existence there. And they come in pairs, so they annihilate each other. And near a black hole, if this process happens, one particle is absorbed by black hole, and the other particle manages to escape out of it, coming into the universe, outer universe. And the outer.
So Bhaskar, you talked about singularity.
Yes, sir.
Suppose I reach singularity, right?
Yes, sir.
Somehow I managed to reach singularity.
Yes.
Then what will be my dimension?
Sir, your dimensions.
Dimensions means my size.
Yes.
Right? Like this bottle. Suppose I throw this bottle to a black
singularity.
Yes. And to a singularity it manages to reach. Then what will be its dimension?
Sir, it will become a 3D object.
It is a 3D object right now.
Yes.
What will be the length, breadth, or height of the bottle?
Sir, it will be compressed down to an infinitely small point, and it won't be able to experience time anymore.
No, I'm not talking about the time.
Sir, then if
I'm just talking about its size.
Sir, then it
what
will be compressed into an infinitely small point.
How much small?
Sir, infinitely small. It cannot be measured actually.
Okay. Will it be converted to energy?
Sir, it is everything is made of energy, so it will be in its energetic form, but it will be in a.
Is this made up of energy?
Yes, sir, it has energy.
This bottle has which type of energy?
Sir, kinetic energy. No, sir, not kinetic.
Okay, you know about Hawking radiation?
Yes.
What is it?
Sir, as I was going to speak, that in vacuum, virtual particles keep popping in and out of existence, and they come in pairs, so they annihilate each other, destroy themselves. So, making it so that the law of second law of thermodynamics is not violated, so the energy of the universe remains the same. But near a black hole, if this process happens, one of the particles goes inside the black hole while the other one barely manages to escape. Making it so that the particle which manages to escape gives the outer universe, the universe which is if we leave out the black hole, the universe, it gives mass to the universe. So that means that the particle that manages to go inside the black hole will need to be a negative particle, so that it decreases the mass of black hole. So the second law of thermodynamics is not valid.
If both the particles, both these virtual particles pop at the same time,
Yes.
at the same place,
So they don't actually come out in the same space.
okay, so where do they come? How much separation is there between
Sir,
them?
actually they are extremely near each other and
Extremely near,
yes, sir.
let us say 1 kilometer, 2 kilometers
Sir,
away,
could be even closer.
even closer, 500 meters.
They could be in an infinitely small gap as well.
Okay, fine. They are very, very close to them.
Yes.
Okay, this is one particle, this is another. How are you sure that this both particles won't go into the black hole? Because black hole absorbs, pulls everything towards it. Why is it that only one particle goes into the black hole, the other particle stays out?
Sir, I'm afraid.
So, do you know what is Schwarzschild radius?
Yes.
What is Schwarzschild radius?
So Schwarzschild radius is the radius that any object needs to. It varies from object to object. It needs to be so that if let's say that bottle there, it needs to be compressed down. The point it needs to be compressed down so that it can become a black hole.
Okay, what's the Schwarzschild radius of sun?
So the Schwarzschild radius of sun would be
Roughly.
sir, half of, you could say, New York City.